Hello YouTube. In this video I'm going to work through a couple of examples in which I just kind of play around with the mechanics again of parabolas with the approach that we take when we do conic sections. Okay, so let's go ahead and start by taking a look at the example that I've got for us here. It says find the focus of the parabola given by y equals negative half x squared minus x plus 1/2. And I say here, note that we need to convert this to the standard form of the equation of a parabola first before or by completing the square. So we're going to find the focus. Basically, let's take into account a few things here. First of all, we see that the x squared is the one being turned. The x squared, the x is the term being squared up here, not the y. So we already know that we've got a parabola. As a matter of fact, we already know this parabola is oriented downward. But basically, we're saying with a parabola, every parabola certainly has an axis running through its vertex. We say it has a focus on the inside of the parabola and a directrix on the outside of the parabola. But we know a few things about this, starting with the equation. So we say either the equation is x minus h quantity squared equals 4p y minus k, if it is oriented like you see on the left here, or if it opens sideways, we say y minus k, the y term is being squared. And we still have a 4p over here, but except be taken times x minus h. So basically what I'm saying here is this. We've already got this kind of in like y equals form. If we could put it into this form right here, then we would know h and we would know k, which would tell us where the vertex is. And then we'd know the directed distance from the vertex to the focus here. We would know this distance here, p, from the vertex to the focus. Anyways, let's go ahead and get started on this. It's a good problem to do. You see this quite a bit of the time. We see our typical definition of a parabola. We want to rewrite it like this, but it involves completing the square. Okay, so our intent, okay, is to make it look like one of these two equations right here. So let's go and get started. We say y equals negative half x squared minus x plus a half. Now, this is just me, but anytime I deal with an equation that has multiple, I like rational numbers, but a lot of fractions involved, I'll just go ahead and multiply the whole thing by the least common denominator. So in this instance, we can see the least common denominator here between everybody's 2. If we were to double everything here, the entire equation, we get a new solution equivalent equation. So we get 2y equals, let's do this. Let's negative double it. So we'd get actually negative 2y equals 2x squared, and we'd say plus 2x. Oh my goodness. Forgive me, YouTube, it is late. And so we say we get positive x squared, positive 2x, and then negative 1 over here. Just to let you know why I did that, with the negative, I wanted my leading term over here on the right to have a positive leading coefficient. As a matter of fact, I prefer to have a positive 1 leading coefficient. In this case, it does. If you want to refresh your video on completing the square, I would suggest you maybe type that into YouTube and check that out. But for right now, I'm going to assume that we do know how to complete the square. So we're going to complete the square on the right-hand side here. And take this into account. We'd say it's in this ax squared plus bx squared plus c form. But it would be able to be completed the square if we took half the middle term, squared it, and got this last term. So instead of having a negative 1 here, I'd rather have half of my middle term, which half of 2 is 1. And 1 squared, square that, you get 1. I'd rather have a positive 1 over here. So what we're going to do is we're going to, temporarily take this 1 and stash it on the other side. So we say negative 2y plus 1 equals x squared plus 2x. So really we just added 1 to both sides. So now I want to point this out here. We get negative 2y plus 1 on the left, okay, plus blank equals x squared plus 2x plus blank. And so we wanted a 1 on the right there, so we'll put a 1. So on the left now we have this, negative 2y plus 2 constants. And on the right here we could say this factors down into x plus half that middle term squared. And so we could say, well, this almost looks like, up top here, we've kind of got an x and h thing going on. It's totally being squared there. Shouldn't the other side look like 4p times y minus k? And it totally should. It's just that we see that we have no y minus k quantity. So the trick here is going to be this. We're going to factor the left-hand side. So we say if we factored out this, say, negative 2, we say negative 2, we'd get this y minus 1 equals x plus 1 squared. So now trust me on this. If I rewrote this as x plus 1 squared equals negative 2 y minus 1, you can start to see how this is related to the x minus h squared equals 4p y minus k. So a few things I want to comment on here. First of all, h and k, we say the vertex here. Now recall that these are kind of backwards here because we have minuses in our formula up here. But we say, okay, so h would actually be negative 1, k would be positive 1. So we say we have our vertex, now we just need p. And you'll notice here that we've got, because of the one-to-one property, 4p, and we have to do a little side work here, is negative 2. So we say, well then, that must mean that p is negative a half. And so here's what we needed. We needed the focus of this parabola, and what we know now is this. It is got a vertex at negative 1, comma 1, and that p is negative a half. So we're actually going to go down, okay? This is a north-south oriented vertex, or our parabola here. And so we'd also go up a half and drop in our directrix here, and we'd say there'd be 2. But basically, we could say here's our parabola here, very poorly drawn, but we were after this focus, and so we say, well, if the vertex is at negative 1, comma 1, then we say then this focus, okay, must be a half a unit lower than that. So we say negative 1, comma a half. And there's our focus, okay? And so just to kind of go through another quick example here. I know that one wasn't very quick, but let's take a look at this. We say find the standard form of the equation of a parabola with the vertex at 2, 1 and focus at 2, 4. So we know the vertex, we know the focus. Let's go ahead and start by sketching an image of what we know about this first. We just kind of see how it's oriented, everything we want to know about it. We say 2, 1. So the vertex is at 2, 1. So we'll go right 2, up 1. Here's our vertex. And we say 2, 4. So 1, 2, 3, 4, 5. So 2, 4 is here. So if this is my vertex and this is my focus, I know that it opens upward, okay? It must open upward. I also know this. I know that the focus, even though I'm drawing this kind of at a weird Hall of Mirrors angle, the axis is at x equals 2 because the focus must be along that. I also know this. P must be 3, and it's a positive 3 because I went from my vertex out to the focus. It was 3 units up. And I also know then, therefore, 3 units down from my vertex along the axis. Kind of going down there. But 3 units down, we say this is the line y equals negative 2. And this is our directrix. So sometimes we want to find the directrix. But basically, just spilling our guts, everything we know about this. But we want to find the standard form of the equation of this parabola. Well, we've written everything we know about it. Let's go ahead and take a look at the standard form. So we see standard form of this equation. It would be a up-down facing parabola. It opened upward. So it's going to be this x minus h quantity squared equals 4p y minus k. Used to this. So we say we need to know h and k. In this instance, we can totally see that h and k, our vertex here, were given to us. We say 2 here and a 1 here. We're going to drop those in. We just need the p. So we say p. Okay, well p, we look over here in the picture, is 3. We can drop this in here. We say this is 3. So now we've got x minus 2 quantity squared equals 4 times 3 y minus 1. So we're going to clean this up a little bit here, but you end up with x minus 2 quantity squared. And then right here we get 12. We just leave it at like 12 y minus 1. You don't have to kick that 12 through there. It's not necessary. So I just want to show you guys this. We say x minus 2 quantity squared, and then 12 times y minus 1. So let's go ahead and take a look at this. We have in parentheses x minus 2 quantity squared equals 12 y minus 1. We say, okay, so take a look at this. We did have a vertex at 2, 1. We have a focus at 2, 4. The directrix must have been the line. We said y equals negative 2 here. You know, it's kind of easy to see that if we were to drop in at least some segments between here and then here in this line, it's not going to let me do it, but those 2 segments, well, it did let me do it. Those 2 segments would be equidistant. I don't know if it let me move. Yeah, it does. Okay. But basically, you know, you can see we ended up with a parabola that we needed to get. So, cheers.